Okay, I said in a previous video that I was going to talk about the social context of science, the application of science, science and technology, and that's what I'm going to do today. And what I want to say straight off is that I'm in large measure reacting against what I think is a common simplistic view that science is an instrument of oppression, that it's always been in the service of colonialism, that it's a Western product. There is some truth, of course, in this, and the truth starts from, I think it starts from a Marxist view. It goes back a long way, but let's say in the 1930s, Lancelot Hogben was writing a Marxist history of science which said early, let's say, geometrists, why was geometry the earliest area of mathematics to be developed? Well, it was about measuring triangles and rectangles and oblongs and odd-shaped pieces of area. And Hogben's argument is that it was of interest because feudal landlords wanted to charge rent. And they charged rent by the area of land, so the measurement of the area of land was important to them. I think if you go back further than that, the ancient Egyptians used geometry to build pyramids, and pyramids were the symbol of power of the most rich and powerful people in the empire, so that it was science was pressed into the service of the most powerful people, and that ties in with the Marxist idea that the ruling ideas are the ideas of the ruling class, that the way science develops is because it's in the interests of the most powerful people in society. And you can follow the argument. I'm not denying that there's something interesting here, that after the Industrial Revolution, Galileo becomes interested in the swinging of a pendulum, the regularity of its movement, and his observations make possible the building of accurate pendulum clocks, that the time can be measured accurately for the first time, not from the movement of the sun through the heavens, but through a mechanical device. And yes, it's then used because labourers in factories, the proletariat, are being required to sell their time. The time has to be measured because they're selling their time by the hour, by the minute. They're forced to clock on, to work in the morning, clock off in the evening. Their life is governed by bells that summon them to lunch or to tea break or to back to work after those breaks, more specifically. And we still organise many of our schools and universities on similar lines. That's science in the service of the bourgeoisie. The capitalist is using science as an instrument of oppression, and some people will feel that as an instrument of oppression, and it was linked to draconian measures like Taylorism and time and motion study, and yes, people did become slaves to the clock. But it wasn't, in my argument, it's not just the clock, it's the clock is being used. Powerful knowledge, science, mathematics, powerful knowledge is being used by powerful people for their own purposes. Yes, of course it is. That doesn't necessarily mean that the people who built it intended it to be used that way, nor does it mean it's the only way that it can be used. You could think of other examples between the geometry and the pendulum. You might think of the compass and maps and navigation being used in the interest of colonialism and of the slave trade, and yes, terrible things were done using science. But my argument is that terrible things would have been done even if the science hadn't been there. It made more powerful and more terrible things bigger scale, but human beings have not always been nice to each other. And my argument is that though there's obviously some truth in this fact that science has been used in particularly negative ways and in particularly to serve the interests of the most powerful in society, that's not the full story. And I'm saying it's not the full story because of this. It's my experience. The reason I fell in love with science in the first place, when I was 11 or 12 years old, we were at school doing experimental geometry. I'm not quite sure I understand the idea of this. We were cutting out triangles of paper and measuring the angles of the triangle with a protractor and adding up the angles and getting something between 175 and 185, depending on how accurate one was in one's cutting and one's measuring. And I didn't understand why we were doing this, because you could look in a book and you could find out that the angles of a triangle add up to 180 degrees. And I said to a friend of my brother, a young man who later went on, I think, to become a distinguished maths teacher, and I said, why are we doing this? And he says, it's preparatory. What you're doing is familiarising yourself with some geometrical concepts, and you're going to move on to Euclid and Euclidean geometry, and this is what's going to happen. And he did what Euclid probably did with his students millennia ago. He took a stick and he drew some patterns on it, and he said, well, you accept that if two lines are parallel, and a line runs across there, you'll accept that this angle is equal to this angle, because they correspond to each other. The two parallel lines, crossing line, those two angles are equal. And you'll accept that these two angles are equal, that one and this one, because they're alternate angles, that they will be the same. Obviously, that you accept those things as intuitively true. And now we're going to do some geometry. We're going to draw a triangle extending one side, and we're going to draw a line in here, a construct parallel to that side. And now you're going to say this angle is equal to that angle because they're corresponding angles. And this angle is equal to that angle because they're alternate angles. And this angle is itself. And you know that dot plus cross plus circle make up 180 degrees, and therefore you know that dot plus cross plus circle add up to 180 degrees. And that's what we set out to prove, that the angles of a triangle add up to 180 degrees. And that struck me, that was a revelation. Struck me that you had started from some simple axioms and you derived something that you didn't know before and was not immediately or intuitively obvious. And the further you went on through geometry, the more unlikely the things that you found seemed to be. The one that struck me as most extraordinary was if you have a circle. Well, that's probably not the middle of the circle. So if you have a circle and you draw this angle and this angle, those two angles are the same. Angles in the same segment of a circle are equal. And that seems to me to be so unlikely that as you move this point round, that angle still stays the same. That seems to be so counterintuitive that you've, starting from simple axioms, can demonstrate something about circles and lines and angles that you didn't know before. That strikes me as extraordinary and powerful as a source of knowledge. And it's something internal to geometry. It's got nothing to do with whether you're using it to measure triangles or whether you're using it to line up artillery or whatever it is you're doing with it. There's something internal about this which is absolutely stunning and which probably, in my view, is the motivation of most scientists. Again, that's I'm including mathematics as a branch of science. But I don't think Galileo had in mind developing a factory system when he was sitting in church watching pendulum candelabras swinging backwards and forwards in time. He was interested in something else, developing an understanding of, if you have a framework of understanding, you can control things, can master things, can find useful purposes. And yes, it's relative. It's a one cockeyed, one-eyed way of looking at the world. It develops your axioms. Axioms. This is what you find is relative to your axioms, but it's a powerful source of knowledge. And let me say, in practical terms, what this means to me. I worked for a long time in the School for Independent Study at what became the University of East London. And the School for Independent Study, I take no credit for having developed it. I arrived late. I was a young lecturer who joined a going concern. And the School for Independent Study was set up by pioneers of education, people like Tyrrell Burgess, John Stevenson, visionaries. And they were reacting to a situation, and the situation that they were reacting to in the 1960s, early 1970s, was the idea that the curriculum of universities, particularly the curriculum of schools in general, were a secret garden. There was an unwritten set of rules that you had to follow in order to be successful in education. And as in the 1960s, universities expanded rapidly. People were going to university who were the first in their family, first generation in their family ever to have attended university. And university professors, university lecturers at that time assumed that the people who were coming to them, like me, had gone to cramming schools that taught you the unwritten rules, how to present an argument, how to write an essay, how to formulate a paragraph, how to write a sentence, all of those things that work, the basic groundwork, the unwritten rules, the university teachers had never had to address because it was everyone they met agreed on the unwritten rules. In the 1960s, that consensus was breaking down because people were entering the universities who hadn't been inducted to the unwritten rules. And so the School for Independent Study said, we're going to make this public. We're going to make this public knowledge. We're going to write down everything that you need to do in order to be successful in this course. And we're going to put it in a student handbook, give it to the students, and everything will be there, and they'll be able to come, they'll be able to say, well, if you do this, if you produce work of this quality, if it meets these criteria, if it's handed in on that date, if you do all these things, you'll get a degree. And it was public knowledge, it was out there. And for me, as a new teacher, new to this system, it was a discipline that I had to learn. A student comes to you and says, when do we have to hand in the assignment? And one's natural reaction, I have to tell you, is to say, I've told you this, it's on the 7th of January, you've got to hand in the work. And we had to learn not to do that. We had to say, it's written in the handbook. Have you read the handbook and have you found the date? And the message we were giving that way was, everything is public knowledge. You need to know what you need to know to be successful here is all written down and available to you. There's nothing hidden going on here. The details of what the assignment was or what the criteria were debated and discussed and negotiated in the early part of the programme. And once the contract was signed, and it was called a contract between the teachers and the learners, then everybody knew what had to be done in order to be successful. And that was a breakthrough. But if you look at what happened since, that led on to the development of outcomes-based education. Everybody started writing university curricula in those terms. They started saying this module will lead to these learning outcomes, and if the student can achieve those learning outcomes, they'll pass the module and they get so many credits. Went very widespread, that whole movement, and now critics looking at that system say, oh, that's transactional. It's if you do this, I'll do that. If you learn this, I'll do that. It's commodifying knowledge. It's turning the person into a self-improvement project. It's a do-it-yourself self-improvement project. Your education is making you into somebody who suitably fits into the capitalist world. It's all done in the service of neoliberalism. Well, it's been used to promote neoliberalism. It's been used, but neoliberalism, my argument is, neoliberalism was happening. That doesn't mean that the motivations of my colleagues at the School for Independent Study, they were generally speaking left-wing, they were generally speaking in favour of emancipating people, emancipatory education. They did not do this in order to serve neoliberalism. They did it to serve their students. And I think that there's great danger if you take an idea like neoliberalism and you try to explain everything in terms of neoliberalism without nuance and you attribute motives to people that they simply didn't have. And I don't think that's wise to do that. But the other thing is that if you have a theory that can explain everything, then it starts to lose its force. Everything is neoliberalism, and frankly, in the literature as we see it and educational research today, that seems to be what people are arguing. If you do this, you're neoliberal. If you do that. If you can explain everything, you end up explaining nothing. I think that's the point that Karl Popper was making when he talked about needing for theories to be refutable. You need to have a theory that can go wrong. What would it look like to have something that was not supportive of neoliberalism? I'm sorry to tell you this, but capitalists are powerful people and they will grab whatever knowledge, process, institution they can to extend their power. That doesn't mean that the knowledge, the institutions and the processes are intrinsically bad or intrinsically capitalist. It means that powerful people will co-opt whatever methods that they can in order to sustain their interests. But as in the case of independent study, things that are developed with actually quite different motives, motive of empowering students, can get subverted towards neoliberalism. And I think that we do need to understand that there's a difference. And the other danger I think for theories that are too comprehensive is also a point made by Popper, is that we're looking for things that are interesting. I hope you're watching these videos because they're interesting. I could make videos that are absolutely true. I could stand here and I could say, I'm going to make a video which includes only things that I'm certain are true. I'm going to tell you 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 4. I'm going to recite a whole things that I know absolutely true. It's either raining outside or it isn't. It's quite cold today or it isn't. And all of those things are true, by definition they're true, but they're not interesting. And what Popper says is that we need to be looking for things that are probably true but interesting, or possibly true but interesting, and I don't make any claim beyond, for what I tell you in these videos, beyond the fact that I think they're probably true. You'll have to make up your own mind about those things though. So we're looking for, what I want to say is that the social context of science is incredibly important. I dare say people are investing in things that they think will make money, and that will affect the direction that science goes in. Sure. Does it mean that because science has been used to make guns and bombs and iron shackles and prisons, does it mean that those were the intentions of the scientists? No, I don't think so. Is that the whole story of science? I don't think so. I think there's something about the internal structure of science, that revelation of something that you didn't know before but is palpably true and useful, is actually so powerful that it means that science is not just another way of looking at the world. It's actually opens up avenues that other ways of looking at the world don't. So there's a long history, as I've said to you, of Marxist interpretations and therefore instrumentalist interpretations of science. I want you to try and avoid those because I think they're simplistic. There's something else going on here within science that makes it worth, and if I may say so, the last thing that I want to say on this issue is that most of the people who dismiss science as a tool of neoliberalism are not very familiar with the internal workings of science itself. They're dismissing something that they don't know about and don't understand. So I'm going to use science in some of my, or mathematics in some of my videos. Don't turn away just because the title says they're about statistics or they're about a mathematical theory. Some of it is powerful knowledge that we can use in developing research in education.